This is the prerequisite review for section 2.7, Analyzing Graphs of Functions and Piecewise Defined Functions. In this worksheet, we are going to cover function notation and also set builder notation and interval notation. So given these functions in objective 1, f of x and g of x, we will find the following: f of t. Let's start with f of t. So f of t, if you would think of f of t, everywhere there's an x, we're going to write a t. So there we will have 6t minus 2. Now let's go to g of a. We will go to the g function, and everywhere there's an x, we're going to put an a. So that is just the opposite of a squared minus 4a plus 1. Looking at number 3, now we'll find f of a. So again, we're going to the f function, and we will have 6a minus 2. And now for number 4, we are going to have f of the opposite of a. So here we will have 6 times the opposite of a minus 2. We will have negative 6a minus 2. Okay. Now let's go ahead and take a look at set builder notation and interval notation. So what we're going to be doing now is they would like us to graph the solution and then write the set in interval notation. So here we first have the set of all x such that x is greater than or equal to 6. So we want to include 6. We want all of the values greater than or equal to 6. So we have boundaries with interval notation. Our left bound is a 6. Our right bound is infinity. We always use parentheses with infinity, and we will use a bracket because we will include the point. So when using either one of these, we want to include the point in the set. If we will use open parentheses or close parentheses, we want to exclude the point. Let me make that open. Let me make these a little bit nicer. So that would be open or close. Okay? Looking at number 6, we would like 2.1, and we want to include 2.1 in our set. And here we would like everything less than or equal to 2.1. Our left bound is negative infinity. Our right bound is 2.1. We want to include 2.1, and we always use parentheses with infinity and negative infinity since we don't have an endpoint. Okay, let's take a look at number 7. So here we have x is greater than 7.3. So we're going to have, 7/3. We have 7/3. We don't want to include 7/3, but we want everything greater than 7/3. So our left bound is 7/3, and we don't want to include it in the set. And then our right bound is positive infinity, and we always use parentheses. X is the set of all x such that x is less than negative 5. So here we have an open circle, an open point, because we don't want to include negative 5. And here we want everything left. Again, left bound is negative infinity, right bound is negative 5, and we use parentheses for both of those endpoints. Okay, Let's look at number 9, the set of all x such that x is greater than or equal to -2. You heard the equal, so we will use a closed point. And as you can see, our left bound is -2, and we do want to include it. Infinity is our right bound, and we don't want to, and we don't use brackets. We always use parentheses. Let's take a look at our last one. Here, let's make a note that this is called a 3, let me use something else. This right here is called a 3-part inequality. They are a set of numbers between two values. So here, let's put a -3 and also a 1 on our number line. We want all of the values less than or equal to 1, so we do want 1, but we want the x values that are greater than -3. And we do have to try to read this backwards. X is greater than -3. So sometimes we do have to read backwards with our inequalities. So writing this in interval notation, our left bound is a -3, and we don't want to include it in our set of numbers. Our right bound is a 1, and we do want to include 1 in the set. And that concludes this worksheet.